We're going to talk about the number e so that we can discuss the natural exponent. So the number e is defined as follows. Right, let's say you have some positive integer n, so n is a positive integer. Now, as n approaches infinity, this arrow here means approaches. So as n gets larger and larger and larger, this in here approaches a number that's called e. To 5 decimal places, e is approximately 2.71828. And really, we should think just to one digit, 2.7. So e is approximately 2.7. So as n approaches infinity, so as we keep getting larger and larger n's here, this is approaching a number, and we call that number e. Now again, e is a number, just like pi is a number. It is not a variable. E is a number. So e to the x is called the natural exponent function. So this is my natural exponent function. So what I want to do is I want to graph e to the x. Now notice there's only 2 places for input here, and that's because I want to go back to what we said before. All exponential functions in that basic shape form have 2 anchor points, and this is a basic shape because it does not have any horizontal shifts or vertical shifts, etc. One of the points is always going to be 0, 1, and then 1a. 1a, well, what is a? A in this case is e. And e, again, is approximately, we're just going to use 2.7. So I have 2 points on my graph. One of them is 0, 1, and the other one is 1, 2.7. So let's put that on our graph here. 0, 1, that's one of my points, and 1, 2.7. Let's call that 2.7. We also know that when these functions are not transformed, that they have a horizontal asymptote at y equals 0. So this also has a horizontal asymptote at y equals 0. And the reason for that is the number 2.7, no matter what power I raise it to, no matter what number I raise it to, I'm never going to get 0, and I'm never going to get a negative number. So that causes that horizontal asymptote. So let's connect those points. And this is the graph of e to the x. Its domain, just like the ones before, is still going to be all real numbers, negative infinity to positive infinity. Its range is 0 because it wants to be 0, but it's not going to be 0. That's why it has a parentheses to infinity. It does not have an x-intercept. Its y-intercept is 0, 1, and its horizontal asymptote is y equals 0. So we are going to be transforming exponential functions, and some of those exponential functions that we're going to be transforming are going to be these that are e to the x. So this is the basic shape for e to the x. Well, let's look at transforming these functions. We can graph any exponential function by transformations. Those transformations, again, were the vertical shift, horizontal shifts, and for these we're only going to look at reflections, no compression stretch. So what we're going to do is we're going to take those anchor points that we know are on there, and those anchor points again are 0, 1, and 1a, and we're going to transform them. We're going to move these points with our vertical shift and our horizontal shift and our reflections. And we're also going to find a new horizontal asymptote. And once we know those 2 points in that horizontal asymptote, we can graph any exponential function. Now please note, the horizontal asymptote is determined by the vertical shift. So whatever my vertical shift is, that is my new horizontal asymptote. All right, let's look at some examples of graphing exponential functions by transformations. It says, obtain the graphs of the following functions by translating, reflecting, and stretching, and give the domain, range, and equations of any asymptotes. So let's go ahead and look at the first one. Well, my first function is f of x equals 2 to the x plus 1. Basic shape for this is f of x equals 2 to the x, right? It's the function of 2 to the x with some kind of transformation. Well, remember, anything here that's with x is always called a horizontal shift. So this is a horizontal shift, and remember the horizontal shifts were always opposite the number there, so a plus 1 moved us left 1. Okay, well, do I have a vertical shift? No, I don't, because I don't have a number that I'm adding out in front of here. So I don't have a vertical shift, and then there's no negative out in front, so I'm not reflecting this. All right, so how do we go about graphing this? Well, first we have to think, what are our anchor points? What are the points that we know would be on this basic shape? Well, those would be 0, 1, and then the point 1, comma. Instead of A, I'm going to write my base, which is 2. Let's start with the point 0, 1. I'm going to actually place the dot at 0, 1, but then we're going to move it to its new location with my transformation. So here's my point 0, 1. Well, what is the transformation for this function? This transformation says I have a horizontal shift of left 1. That's the only thing that I have. So this point needs to go left 1 unit. It goes right there. So this point has now shifted to negative 1, 1. I'm going to erase that 0, 1 on there. Let's look at the point 1, 2. The point 1, 2 was right here. Well, according to my shift for this function, I needed to move this point left 1 unit. So 1, 2 becomes 0, 2. Those two are the two new points for my graph. Then my horizontal asymptote. Well, the horizontal asymptote is going to be y equals 0 unless you have a vertical shift. Well, this problem does not have a vertical shift, so my horizontal asymptote is going to stay as y equals 0. So let's go ahead and draw in my horizontal asymptote. So with those two new points and that horizontal asymptote, that's all I need to graph my function. So what you do when you're graphing these functions is you know your anchor points and then you move them according to your transformation. All that's left is to find domain and range. Well, domain, arrow, and arrow is still going to be negative infinity to positive infinity. And range, they still want to be 0 going all the way to positive infinity. All right, let's look at example 5. Same thing. We have a horizontal shift here of left 1, and then this plus 3 out here is my vertical shift telling me that I'm going to go up 3. So I have a vertical shift of up 3 and a horizontal shift of left 1. Well, this actually is the first time I have a vertical shift. Well, vertical shift determines my new asymptote. So instead of having a horizontal asymptote at y equals 0, my vertical shift says, hey, you have a horizontal asymptote now at y equals 3. Why is it at y equal 3? Because I'm plus 3, I'm moving up 3, so this horizontal asymptote moves up 3 units. Well, what are the anchor points? Well, the anchor points, my base is 2, that would have been 0, 1, and the point 1, 2. All right, now let's put those anchor points and move them with our shifts. So here's the point 0, 1. My horizontal shift says move it 1 to the left, vertical shift says move it up 3 units. So here is my new point. Well, what is the location of this point? This point is negative 1, 4. So it changed and became the point negative 1, 4. Okay, well, what about the point 1, 2? Where does that one lie now? Well, here was the point 1, 2, and I know that I need to move it 1 unit to the left and then 3 units up, so it becomes the point 0, 5. So there are my 2 points. So the only things that I need to graph these exponential functions are the 2 points and my horizontal asymptote. Well, my horizontal asymptote, remember, that moves with your vertical shift, so it's y equal 3. So there's my horizontal asymptote. Connect those 2 points with the same shape, and I'm done. There's the graph of f of x equals 2 to the x plus 1 plus 3. Finding domain and range of it. Domain, we have an arrow and an arrow, so negative infinity to positive infinity. In range, well, the lowest I want to be is 3, and it's 3 to infinity. Let's look at the last two. I have negative 2x plus 1. So same thing. Well, this negative out in front tells me I need to reflect. And when you reflect, you're going to go to the other side of the x-axis. I don't have a horizontal shift, but I have a vertical shift that tells me to go up 1. Because I have a vertical shift, I know that that means that my horizontal asymptote changes to y equal 1. The 2 points that should be on here, 0, 1, and the point 1, 2, because my base is 2. Well, I need to transform them. So let's start with the point 0, 1. That's where 0, 1 is. If I need to reflect 0, 1 on the other side of the x-axis, 0, 1 becomes 0, negative 1. So I'm mirroring it on the other side of my x-axis. It became the point 0, negative 1. And then I need to move the point up 1 unit. Well, that puts me right here at 0, 0. So this point, 0, 1, with my shift and my reflection, became the point 0, 0. Please note you must reflect first and then do any kind of vertical or horizontal shifts. Again, you must reflect first. If you have a reflection, you must reflect first and then do other shifts. Well, let's do the point 1, 2. Same thing, here's 1, 2. So if I need to reflect it on the other side of the x-axis, it's going to go down and it's going to become the point 1, negative 2. Well, then I need to move that point up 1 unit because that's what my vertical shift says. So it goes right there. So that became the point 1, negative 1. So that became the point 1, negative 1. Well, what was my horizontal asymptote? My horizontal asymptote was y equal 1 because that went with my vertical shift. So then I just need to connect the points and draw my graph. Now the reason that the graph is pointing downward is, remember the way that reflections works, and I'm going to draw something over here and then erase it. If my graphs typically look like this and I'm reflected on the other side of the x-axis, well, I have to look exactly the same on the other side, so I'm going to look in this format. So the reason that it's aimed downward is again because I'm reflected. All that's left is to find the domain and range of this. Well, domain, arrow, and arrow, that means negative infinity to positive infinity. My range, well, my lowest value is this arrow here. That means negative infinity. And the highest, well, I'm trying to be y equal 1, but I'm never going to get there, so the highest I go is 1. So the reflection changed our range as well. Let's look at example 7. So let's see what we have here. We have a horizontal shift of right 1 and a vertical shift of down 3. Because I have a vertical shift, that means that my new horizontal asymptote is going to be at y equal negative 3. Now I need to find my anchor points. So I'm going to have the point 0, 1 and the point 1a. Well, a is the base and my base is e, and we know we can approximate that to 2.7. So my 2 points are 0, 1 and 1, 2.7. So here's 0, 1. What I need to do to it is go 1 to the right and then down 3 units. So here's the location of my new point. So this point became 1, negative 2. The other point, 1, 2.7, right there, it needs to go right 1 unit, and then it needs to go down 3 units. So down 1, 2, 3. So this becomes the point 2, comma, and that would be actually negative 0.3. So 2, comma, negative 0.3. All right, well, let's put in our horizontal asymptote here at y equal negative 3. Connect our 2 points. And that's the graph of f of x equals e to the x minus 1 minus 3. Let's find the domain. Arrow and arrow, that's going to be negative infinity to positive infinity. And the range, smallest, well, I really want to be negative 3, but I can't. Highest is an arrow, positive infinity. All right, so when you're graphing exponential functions, you want to find those anchor points, right? The anchor points are always going to be 0, 1, and then 1, comma a. So you just got to find the base in your problem. And the vertical shift determines your new asymptote. So find your vertical shift and your horizontal shift. All you have to do is take those points and put them where they belong according to those transformations. That's it for exponential functions.